Okay, now I'll again write since these are all word problems, I'll write the same word problem. Let's take the same water tank. A water tank is in the shape of a upside down cone with radius something meter and height something meter. Okay, so I'll ask you numbers for these. So the water is running out. Okay, so suppose we are pumping in water. We are pumping in water at the constant rate of something. Again, you'll give me some numbers. So you see that we are in the same situation. Okay, we have V prime. Okay, so V prime is now we can ask something. Okay, we know V prime. Okay, so for example, we can ask the height. Okay, but if we want to ask the height, okay, so this is the equation. We can ask the height, then we have to give h prime. Okay, so in this problem, h prime is given, height is asked. In order to make this complicated, we can also ask r, okay, because r and h are related like this. Okay, but let's continue with this. So let's say we want to ask h. Okay, what is the height of the? Okay, let's say what is the level? Or okay, what is the height of the water? Water in the tank when the water level is increasing at a rate of something. Okay, so at the rate of, here we want some number, height is some number, pumping in water and radius. Okay. So let's give some numbers. Okay, so what do you want your tank to look like? What do you want the radius and height to be? You don't want to do anything with the water tank? You want 8 for this? Okay, 8 meter cubic meters per second, minute. Okay, let's make minute. Okay, give me 3 more numbers.
Radius and height 1.
Radius is?
1.
1. Okay. Height? 2. You will make very sweet instructors. Okay, so give us a rate for the water level increase? 5. Okay. So how can it increase 5 when the height is only 2? Okay, so let's make this 20. Let's make it 27 to make calculations horrible. So I want it to look horrible. And let's make this 13 so half of the class is scared. Okay, 8 is okay. I don't want to make it 81. So now your 5 is okay. So I did all this to save your 5. It's 5 meters per minute. Okay, so that's how you, of course, this is not how you cook up a problem. You put A, B, C, D there. You solve the problem. In the final expression, you have an complicated expression in A, B, C, D. Then you start giving numbers there, so the answer will be pi over 3. Okay, so that's why all calculus problems have answered as pi over 3. Okay, so let's see if these random numbers, what will happen. So solution, okay, so I keep using blue, so let me continue with blue, if I can find my blue. Solution. Okay, we'll draw again our picture. So radius is 13. This height is 27. And we have water level here. Let me continue with that. So things that we got used to. Here we have some water level. Okay, so this part is we don't know. Okay, so but we know that this is increasing at a rate of 5 meters per minute. And water is pouring in. Okay, so water is pouring in at 8 m³ per minute. So this is meters per minute. These are minutes. So I try to avoid these units, but they catch me. Okay, so it is this part. So I again do my triangle so that I can solve things. Okay, so this part is H. This part is R. This is 13. This part is 27. So I had 13 over 27 equals R over H. Okay, so with these things, it's generally easier to find H. Okay, so and R is equal to 13H over 27. Okay, so I write the volume. Volume is pi over 3 R square H. Okay, then I substitute in pi over 3 13H over 27 square H. Okay, so this is what 169 pi over I don't want to do this. So this is 3 to the 3 4 4 H cube. Okay. Az mı oldu? 3 6 7 olacak değil mi? This is 3 cube. Okay, if I square it, I'll have 3 to the power 6. I have one more 3 for some reason. Then I'll have 3 7. Okay. So there I said this is my V. This is my key equation. Now take derivatives. Okay, so okay, so V prime is equal to 169 pi over 3 to the power 6 H square H prime. Okay, put in values. Okay, now we read the story again. V prime is 8, but is it plus or minus? Water is poured in, so it's increasing. V prime is plus. We take it with plus 8, 169 pi over 3 to the power 6 times H. H is not given. Well, in fact, it is us. What is the height? So H square remains H square. When the water level is increasing at a rate of 5. Okay, so it is plus 5. Okay, so you see that only H square is unknown. So let's see how we can solve for this. H square is equal to 8, 3 to the power 6 divided by 5 times 169 pi. Okay, so H is equal to this is 2 times square root 2, 3, 3. No, okay, so, and where are we? This is, well, all of this is squared. Square root of this is 13, 5 pi meters. Okay, so the answer at that instance, okay, so let's use a different word to show off our vocabulary. At that instance, the height of the water water is this horrible number. 2 square root 2. Well, this is 27, 13, 5 pi meters. If all the calculations are correct, now then you go back and check your calculations. Okay? So I deliberately followed the same procedure because this is what you do. You calmly follow equations, take derivatives, plug in numbers. Okay? The story can be complicated, the problem can be complicated, but the procedure is simple. You cook up a nice equation summarizing what's happening. You take the derivative of both sides, and then reading the story, you start plugging numbers. If it's a correctly formulated problem, only one unknown will remain, and you'll solve for it. Okay, so let's see, what else do we have? Okay, now let's solve problems from the book. Well, I solved 5 problems for you, so now it's your turn. I'll write problems from here, and you'll tell me what to do. So let me erase this. Okay, let me invent a problem for you, and you solve it for us. So this is number 6. This is another of favorite problems in calculus exams. A light, or rather let's say a searchlight, is placed. Again, you'll give me some numbers, meters away from the shore, which is a straight line because this is a calculus problem. Okay. The light is turning at a rate of so many revolutions per minute. Okay. So we have to find something. Okay. How fast is the light? How fast is the tip of the light at the shore is moving when it is so many meters away from the base of the line joining the lighthouse to the shore. Okay, so I hope this is a reasonable problem. Okay. So give me 3 numbers. How many meters do you want to place this away from the shore? Not 1 meter. Okay, some numbers. 5. How many revolutions do you want this thing to make? 10 revolutions per minute. How many meters away from the, well, 5, 10, 15 as you are going. Okay. So let's see if this is a related race or just a derivative problem. I just cooked it up. I don't know if it is related race because nothing seems to be changing here. Okay, so solution. So we have this shore, this is sea, and 5 meters away we have this light, okay, and the light is turning, okay. So at a certain time, when it is theta here. So this is the tip of the light. And this side is, let's say, x. Okay? And x is moving in this direction. Okay? So x prime. So I think this turned out to be just a derivative problem. I should have made this change also, but okay. So this is what we have. Okay, so I have in this case I'm trying to find x prime. Okay, so x over 5 is equal to tangent theta, right? Take derivatives of both sides with respect to time, because this is changing as time is changing. So x prime 5 is equal to theta prime secant square theta. Okay. Well, this is not related race, but a nice calculus problem. So what is theta prime? How many radians? So theta prime is so many radians per minute. How many radians per minute is this doing? 10 revolutions per minute. 20 pi. Okay, so this is 20 pi per minute. Okay. Okay, so what is secant theta? At that time is equal to, so I have to find this side, right? This is 25 plus x squared. And secant theta is 5 over this number. No, this number over 5. Which one? What is secant? What is the secant of an angle? Is everyone sleeping here on this side? What is secant of theta in this triangle? What is cosine of theta?
Square root 25 plus second.
So you are saying secant?
Yeah.
This over this.
Yeah.
Okay. 25 plus x squared over 5. Okay, so we want to calculate this when it is 50 meters away. Okay, so x is 15. Put x equals 15. Okay, because that's when we want to calculate this. Okay, so this is 25 plus, what is 15 squared? 225. Eh? Okay, so 5, so this is 250 over 5. We can also simplify this. This is square root 10, right? This is equal to square root 10. Okay, so this was our equation. So x prime is equal to 5 theta prime secant square theta. Put in numbers. 5 theta prime we find to be 20 pi over nothing. Okay, so it's just 20 pi. And secant was square root of 10, so secant square is 10. Okay, so 1000 pi. 1000 pi. So what is the unit? Meters per minute. So 3 kilometers per minute. Well, that's expected, right? Because as this moves like this, so this thing speeds up. Okay? It even passes the speed of light. How come it passes the speed of light? Either calculus is wrong or physics is wrong. Okay, so you figure it out. Okay, so let me find some questions from the book. Okay, so this is a snowball melts so that its surface area decreases at a certain rate. Then find radius or volume, whatever. Okay, so let's do that. Okay, now I want to write this problem. If a snowball melts so that its surface area decreases, if a snowball melts so that its surface area decreases at a rate of 1 centimeter square per minute. At a rate of 1 square centimeter per minute. Okay. Find the rate at which the diameter decreases. Find the rate at which the diameter decreases. Of course, if you put a full stop here, the problem is not well defined, okay, because we need one more data here. Okay, just consider the surface area formula. You take its derivative. Okay, so the derivative has r and r prime. So here r prime is asked, so we must have r. Okay, when the diameter is 10 centimeter. When the diameter is 10 centimeters. Okay, so solution. You'll solve this, so don't look at me. So what is the first thing? Well, we can draw a picture, but here the picture will not help because everything depends on maybe in the picture we have this diameter, this is D, and S surface area. Okay, so the question is to find D prime with respect to time. So this depends on time. D prime is 1. Okay, so this is all we can get from the picture. Okay, so what is the first thing we do after the optional picture? We need a formula to take derivatives. Okay, this is calculus. We want to take derivative of something. So give us something.
4 pi r squared.
What is 4 pi r squared? Surface area. S. Okay, so S is equal to, so our formula is surface area is equal to 4 pi r squared, right? Well, I want to write everything in this form. This is 4 pi diameter over 2 square. So this is pi d square. Okay, so I wrote everything in terms of diameter. Before doing anything else, let's take the derivative. Okay, so remember that this is calculus, so we take the derivative and then we start thinking. So this is S. All depend on time. So we take the derivative here. S prime is equal to 2 pi d prime. Okay. What next?
Put 1 centimeter square.
Okay, let's put numbers here. S prime is 1, so put in numbers. S prime is 1. 2 pi, d is 10, okay, 10, d prime. Okay, so solve. d prime is equal to 1 over 20 pi. Let's put in numbers, centimeter per minute. So that's the solution of the calculus problem. Now we write a human sentence to answer the question. The question is, find the rate at which the diameter decreases when the diameter is 10 centimeters. So answer, when the diameter is 10 centimeter, it is increasing, it is decreasing. Well, why didn't we get minus? Here it says decreases, okay, so it must be minus here. Okay, so this is minus. It is decreasing at the rate of 1 over 20 pi centimeter per minute. Okay, so this is how you solve such a thing. Again, the important thing is to visualize in your mind what the situation is. If it will help, draw a picture, put your variables here so that you can refer back to this. Then write a formula about the story here, okay? So several variables are given in the story. We are assuming that the story is correct, okay? So the variables of the story are related like this. So we simplify it here. So this relates the surface area and the diameter, okay? And then at this point, we don't know what to do, so we take the derivative, okay? After we take the derivative, now we have an idea. We realize that of these three variables, two of them are given in the problem. We put them in and solve for the remaining, and that's what is asked. And then we say the number you asked is this thing, okay? And again, we try to be careful that we don't talk about minuses or pluses. We incorporate that into the meaning of the sentence. Here, it is decreasing. Okay. Okay, let's look at another thing. A street light. Also, this is another problem. Every time you can build up a triangle, you can ask a related race problem. So let me write this story. A street light is mounted at the top of a 6-meter tall pole. Well, 6 meters is huge, but this is a problem. A street light is mounted at the top of a 6-meter high, 6-meter tall pole. Okay. A man 2 meters tall, a basketball player. Okay, let's say a basketball player is walking of height 2 meters. Walks away from the wall, walks away from the pole. With the speed of 1.5 meters per second. Well, this is not walk, so it's running. Okay, so let's make running. Runs away because there is a dog chasing her. Runs away from the pole. With the speed of 1.5 meters per second. How fast is the tip of the shadow of tip of her shadow moving when she is 10 meters from the pole. Okay, so let's talk about this. Okay. So we can figure out, we can visualize in our mind what's happening. Okay, so there is this fixed light, but when you walk away, okay, the shadow also walks away. So how fast is it moving? Okay, so we draw a picture so that we can put in our variables. Okay, so you see that there are no variables in the story. So as the answer, if you say x prime is equal to 7, okay, so there's nothing here. There's no x here. Okay, so these symbols, names, is for you to solve your calculus problem. After you get the calculus problem, you solve the calculus problem, you interpret this thing. Okay? So your question? Yeah, oh, you are thinking. Okay, so let's think together. So this is the pole of 6 meters. Okay? So there is the shadow, and if this is 6, maybe this is 10. And this is also always fixed, 2. Okay? So we are interested in how fast this thing is moving. So let's give this whole thing a name. So let's say this is x of t. Okay, so we want x prime t is what? That's the that's the question. And so since the speed is given, this thing is changing. So let us call this y of t. Okay, so then this part is x of t minus t. That's, we will see. We know that y prime is 1.5. Okay, and we want to find x prime. Okay, so this part is x minus y. Okay, so let's relate these things. Okay, so 2 over 6 is equal to x minus y over x. Okay, so this is 1 over 3. So this gives, okay, so this is 1 over 3. So we have 3x minus 3y is equal to x. And y is equal to 2 over 3. Okay, so 2 over 3x. For some reason, I didn't get to use 1.5. Okay, so let's see. Okay, so what do we do? If I take the derivative of this, I'll just get x prime. Hmm? Yes? Any ideas?
Don't we need the derivative of x minus y?
No, we want to see how fast the tip of the shadow is moving. This is it.
Shadow starts after the 2 meters. You say we need the derivative of...
No, yeah, you are right, but then that tells me how fast the shadow is increasing. Okay, so if I take the derivative of this, that tells me how fast the shadow is increasing. Okay, we want to know how fast this thing is moving. Okay, so then I have to take derivative of x prime. Okay, so, well, actually I need x here. X is 3 over 2 y. Okay, so here x prime is 3 over 2 y prime. Y prime is given as 1.5. Okay, so this is 3 over 2. Y prime is again 3 over 2. I find 9 over 4. But somehow we missed something because I didn't use this 10 meter stuff. I didn't use that at the moment when this is 10. Okay, so think about this. So where did we go wrong? Okay, exercise, find the error. So I'll probably correct this later on the website. Okay, another problem of this sort is when a car is moving in one direction, another car is moving at another direction, and we want to find the actual distance between them and how this distance changes. Okay, so that's a typical right angle problem. We find the hypotenuse in terms of the sides, then take the derivatives. Okay, so there are 4 values there, and if they are all known, we can find how fast the hypotenuse is changing. So let's do something like that. So number 9. Okay, so well, these problems generally talk about northeast, etc. So let me say a car is moving at a rate of, say, 80 kilometers per hour. Okay, let's make this on the xy along along x-axis towards the origin. Okay. Another car is moving at a speed of, say, 70 kilometers per hour along y-axis away from the origin. Okay. So what can we ask? How fast are they approaching to each other? When the first car is 200 kilometers away from the origin. So the car is in Afyon, coming towards Ankara. The other car is going towards Konya. And the other car is, okay, so let's make it 120 kilometers away from the origin. Okay, so we draw a picture, solution. We draw a picture like this, x-axis, y-axis. So suppose the car is here and the distance from the origin is x. It is moving in this direction. The other car is here. This distance is y of t. It is moving in this direction. The distance between them is this, and we suppose for some reason that that distance is decreasing. Okay, so we don't know. We'll find out. Okay, so this is the distance between them, and the rate of change of d is asked. How fast are they coming close to each other, or is the distance between them increasing? Okay, so you see, first we have to write an equation for d. d is x squared plus y squared, right? d squared is equal to x squared plus y squared. Take derivatives. Okay, I have 2 everywhere, so I just cancel 2's from the beginning. I have d prime is equal to x prime plus y prime. Okay. Put in numbers. Okay, d I don't know, but you see if one of them is 200, if this one is 200 and the other one is 120. That determines what d is. So d is square root of 200 square plus 120 square. D prime is what I want to find out. X is 200. X prime is 80 kilometers, but it is moving in this direction, so this is minus 80, plus y is 120, right? 120, and it is moving, what is the 70? It is plus because it is going in that direction. Okay, so from here solve for d prime. So d prime is minus plus, what is this, 84 over this. Okay, so, well, actually it turned out to be negative. So d prime is decreasing. It means the cars are approaching to each other. Okay, so we solve this. Anyone has a calculator? So this is minus something. Okay, you pay so much money for this calculator. It's time to use it. Nobody has a calculator here? Don't you have applets on your smartphones? You just show it here, focus it, and it gives you the answer. There is such an applet. You know that? You show the equation to the phone, you focus it, and it gives you the answer. Kaç buldun? Bekliyoruz peki. One brave man is doing our calculation. So you'll give us the number, I'm writing it here. The cars, since this is decreasing, they are approaching. The cars are approaching each other at the speed of so many kilometers per hour. So here we are waiting for the number. What is it approximately? Minus what? 600. Something. Okay, so let's say approximately.
No, but it's smaller than this.
Huh?
It's smaller than this.
It can't be like this.
No, yeah.
So,
Divided by minus 233.
no, you divide and give us an approximate number here. So divide those numbers and give us an approximate numbers. So a reasonable number. So it must be very small. It must be a very small number. 30. So this is approximately 30. So this is 30 kilometers per hour. Okay. Thank you. Okay. So it makes sense here because the cars are. The difference between the speed is small. So you don't expect this thing to be suddenly 1,000. Okay.